what's n in your Cmax equation? Was that the number of qubits again?
Yeah, so n, big N, and every time it appears here will be the number of qubits. Will
the
the
number of gates to the n and not dependent on time?
This here is asking how many circuits can I build which have exactly which have a number of gates equal to have some number of gates. And so the reason it's n squared to the number of gates is that each time I lay down a new gate, I have, if it's a 2 local gate, I have n squared possible options for where I can put it down. And so the number of possible circuits I can build goes like n squared to the number of gates.
And then why did the number of gates drop out of the next equation?
So this is a counting argument. And the counting argument says, so that the complexity is equal to the number of gates. So it's sort of still there, it's just called Cmax. But the definition of complexity isn't how many gates are there in the circuit that built your state. The definition of complexity is how many gates are there in the smallest possible circuit that could build your state. And that's why this counting argument gives a maximum to the complexity. There's clearly no limit, there's no theoretical limit to the number of gates you could put in a quantum circuit. But eventually you'll get collisions and it'll just stop being an optimal circuit and it'll be a compressible circuit. And that will happen, I mean, a counting argument suggests that that will happen when you have laid down an exponential number of gates. Not typically before and typically not after. Just if I'm just going on the basis of counting the number of circuits and counting the number of states in the Hilbert space, I would say that it goes exponentially in n.
I think we should take further questions.
Okay. Well, I am aware that I have formulated the conjecture to you and explained to you what it is and not given you any reason whatsoever to believe the conjecture. But that is just the price you're going to have to pay. Except I'm going to sort of assure you that there are in fact good reasons to believe that there are properties of complexity that this holographic construction captures. Some sort of coarse-grained properties of complexity, and there's even a sort of beautiful cancellation that happens where if you start perturbing the quantum side, you see the chaotic growth of the perturbation on the complexity side, and that has a gravitational jewel on the other side as well. Okay, that's the conjecture. Thank you.